Now, many of you have heard of the additional protocol, right? How many have heard of that? Hands. Okay, well, after the embarrassment of Iraq, where it had been a country that had been inspected by the IAEA, and right under the inspectors' noses in buildings they didn't go to that were next door to the buildings they went to, was a weapons program. And they went, oh, well, the system worked, but the system's terrible. So they came up with a bunch of new rules, and they got everyone, well, mostly everyone. Saudi Arabia, by the way, is very uneasy about signing up to this. Most everyone to say, okay, we'll agree to those new rules. And those new rules allow the agency to actually cross the street and go to the other building if they think they have reason to, roughly. So everyone celebrates, well, the additional protocol, yeah? What most people don't know, though, is that bringing the additional protocol into force is very stressful on staff time, because you have to first make a determination, oh, the country in question does not have any undeclared facilities and or materials. Good luck figuring that out. Takes a lot of effort. Now, eventually, over time, it does save staff time, but only 5% was what I was told by the IAEA. But that's not the real problem with it. The real problem with the additional protocol is once you get the good seal of approval, you don't get inspected as frequently. So instead of going to that light water reactor to see if there are any fuel rods missing, every 90 days you do it once a year. Okay, I guess that's a good idea. You can see there's a problem there. When people use this phrase, oh, well, that's the gold standard, if you will, for safeguarding, I think people need to know operationally, well, how does it work? It's not an end-all be-all. It's of some value, but it comes at a cost, if you will. Yeah? All right, there is another thing that people do not appreciate, and that is that when the IAEA was created in the 50s, and when they came up with what the frequency should be of the inspections, they call it the timeliness detection goals. They did it on the basis of how long it would take to convert material into a bomb core. Not a bomb, but the bomb core, the two, in the case of highly enriched uranium, perhaps, two subcritical masses, or more likely, they should have been thinking about also just a hemispherical subcritical core. All right, so to do that, they had to know also how much material do you need to make a bomb. They call that a significant quantity. So to get a significant quantity, you wanted to make sure that it took more time to get that than the frequency of the inspections over the material. That's logical. Yeah. So the first problem was they kind of went generous on what the numbers should be. Now this is the chart that I showed you in the lecture on bomb design, which is roughly low would be Mark III, that would be 1945. Medium would be, I don't know, 1951 or something. And high would be, I guess, thermonuclear. So let's say, early 60s, okay? Design. And you'll notice that all of the numbers associated with plutonium, but the low one with a high yield, well, actually all the numbers, excuse me, all of the numbers are what? What is the number for the IAEA? Oh, 8. Well, holy cow, where's 8? There's no 8 up there. Everything's lower than 8. Oops. Oh, well, that's because you'll need more than, 6 to get 6. There'll be a lot of plutonium on the floor. It'll be lost in the pipes. So they already kind of... Also, in the early days, people didn't want to give them the exact number. So everybody was happy with a big number because it wasn't the real number. You'll notice the same thing with the highly enriched uranium. So you're already off to kind of a weird start. Then I did a study as part of that, falling behind. I said, well, what are the timeliness detection goals versus the conversion times? Well, the conversion times for separated plutonium and highly enriched uranium are in the order of 7 to 10 days. Now, here things sort of work because excuse me, I'm going to have to move because here we go. So the official timeliness detection goal isn't 7 to 10 days, it's a month. Does anybody see a problem, and what is the problem? Oh, come on, there must be one of you who sees it. If you can convert something in 7 to 10 days, but you only inspect once every month, what could happen? They could convert, and you wouldn't know until after they said, hey, over here, it's a bomb. Surprise! Right? Not a good look, as my wife would say. If you have plutonium in mixed oxide fuel, the conversion, by the way, these are fairly generous. I mean, I think actually the conversion time could be as little as a day or two. So, we're given plenty of room here. It's 1 to 3 days, weeks, 1 to 3 weeks, but you're back to a month. If you have spent fuel and you got plutonium in it, this one looks a little bit better. It's an order of 1 to 3 months. 1 to 3 months. But it's 3 months. And then low enriched uranium, see, this is unirradiated, I think. Low, was it? Let me guess. This is irradiated, and this is fresh. They say they take an order of 3 to 12 months to turn that into highly enriched uranium. Well, I think that's probably more like 3 to 12 days with a centrifuge, but okay, let's go, 3 to 12 weeks. But they only visit once a year. And of course, under the additional protocol, all these things go further out. So that's a problem, I think. Now, it's interesting, the deputy director retired, Ali Honanen, now says we need to change and update the figures, that the significant quantities need to be lower. Okay? Now, but when you do that, these dates go down. And when you do that, the staffing requirements go up. And the budget has to, oh wow, you see how this works? Interesting.